Next curve.
Hey everyone, welcome to this Next Curve Rethink podcast, where we will be recapping Intel's Technology Tour 2024, and I'm Leonard Lee, Executive Analyst at Next Curve, and I'm joined by two really awesome dudes. They just happen to be analysts, and some of the leading analysts in the industry covering all things tech as well as semiconductor, anything that has a chip in it. So we have Jim McGregor of Tirias Research. He's the founder and principal. And we have Dave Altavilla, right?
He got it right.
Not just any hot hardware, it's hot, right?
It's hot hardware and HotTech. HotTech's the analyst firm. And if it's hot, we're on it. If it's not, we kind of don't care.
I love that. That's great. So, but yeah, you know what? We were fortunate enough to have. Well, we had the privilege of being invited to Intel's, tech tour program this year. And it took place in Taipei, Taiwan, a week just before Computex 2024. And, all three of us were there live. And I wanted to see if we could talk about and share with our audience here some of our key takes as well as impressions that we walked away with from that event. And there was a lot that was covered, right? I mean, and this was like the third installment, right? It's sort of a new program, relatively speaking. And this year, it was a lot of it was about AI, right?
Go figure.
AI.
Maybe there's something to this trend. I don't know.
Yeah.
Seems to think so.
Actually, it's you say there was so much covered, and I'll be honest with you. The more discussions and more questions I ask, the more detail I get. So it's amazing that despite everything that was covered, they still didn't cover it all.
Yeah. Yeah, go ahead.
Some of the players were close to the vest a little bit, and others were a little bit more forthcoming, like Intel with their Lunar Lake dive really went, full open kimono and gave us a real look under the hood. But yeah, Jim, I mean, it's also a learning process for us, right? As we get the data dump from everybody on this, and everybody seemed to hit all at once. AMD, Intel, Qualcomm, NVIDIA. It was chirping too, and of course, so
and there's still more information coming out. We should probably highlight that in the fact that AMD didn't give all the details on their chip. Right. Intel talked about their new server roadmap and their new processes, but we still don't have all the details. That's going to be coming out over the next couple of weeks as well. So there's still a lot of information, both on the PC side and on the server side, that we're going to still see a lot of, and even on the process side that we're going to see over probably the next 8 weeks.
Yeah.
No rest for the wicked.
Yeah, definitely not. and wow, we're going to be having a busy year this year. But Dave, you mentioned Lunar Lake, so maybe we start off with that because AI PC was the big deal, right? And I think it is a very interesting time, to put it lightly, for Intel in this space, especially given the announcements coming out of Microsoft Build 2024, where Copilot PC, that program was announced, and I think it was pretty clear Microsoft is pretty close to the vest with very tied together with Qualcomm and their Snapdragon X series in this launch. And so, I don't know, what were some of your key takes from the presentations related to Lunar Lake?
Yeah, interesting. You frame it that way, and I think that whole build launch really stung for Intel, obviously, and where it's been Wintel and the partnership for eons now, and to see that was a major shift. I think what was impressive to me not only was the new architecture Intel stepped forward with, which is very different than previous gen Meteor Lake, but also the confidence that their executives had in the product, and claiming, it's not here until September, but demoing it live, at the ITT, the Intel Tech Tour we had in Taiwan prior to Computex, demoing it live, and then saying, we're going to smoke everybody. We're going to smoke Apple. We're going to smoke Qualcomm. We're going to, in general, just being very, very bullish on it. Now, I expect, my key takeaway from Lunar Lake is I think you're going to see a very strong GPU. I think you're going to see a very strong NPU, 48 tops. CPU is going to be interesting. I think probably, king in single-threaded performance. We'll have to see how that shakes out. Multi-threaded with a 4+4 architecture, 8 cores total, E-core and performance core. Multi-threaded, probably going to come up a little bit short. Just my gut, just from core count, comparison. But really, their executives think, they're going to be back on top in the laptop space, thin and light laptops with the AI PC.
Yeah.
So,
it's funny because what we've seen is, especially with Apple launching with their own ARM architecture, it was all about having, and I'm going to be very specific about ARM compatible architecture. It is a custom architecture, just uses the ARM ISA.
It's the ISA,
and then Qualcomm, this is their first Snapdragon chip with an ARM compatible with their own custom core. So, I think Microsoft really wanted to show that they could have that low power solution that competes with Apple. But, Intel came out and said, listen, x86 can do this too. And the thing that really stood out to me was they came out with this new E-core, and it's this efficient core. It's real drastically different than not just the cores, but the whole system, the chip architecture. They think they're going to be highly competitive with these custom ARM compatible architectures. And to be honest with you, I think they are. It's going to be interesting. Now, I don't think it's a slam dunk. I think it's going to be very competitive, but to see the x86, be designed for this very low power solution, this low power mode, and to be competitive with these architectures, I think it's going to be interesting. And they didn't pull any punches. They expect it to be, a complete platform AI solution, not just focused on the NPU, even though they will be very competitive there. And they're still going to be using TSMC for their foundry for this Lunar Lake architecture, but they laid out even a path for future products with Panther Lake, where they're going to be using their own process technology going forward with Intel 18A. So you got to look at them and say, listen, and that's the thing we've always said about Intel is never count them out. So they are. You got to remember that they've got the process technology and they're firing on all cylinders there with 5 nodes in 4 years. And now they're coming out with a product where they're breaking down the architecture in ways that they've never done. Instead of doing hyper-threading, which they've always done, and with a single type of core, now they're kind of breaking it up into these performance and efficiency cores, very much like what we see in the smartphone with the ARM architecture with the big and little cores. So it's going to be interesting. I think there's a learning curve for everyone in this market, and I think the PC is definitely an inflection point.
Yeah. And it is truly a rethinking and re-architecting, especially if you look at Lunar Lake vis-a-vis Meteor Lake. I mean, they just don't look the same. Right?
Oh, drastically different.
It's just so different. And the way I looked at it is they did a significant amount of consolidation and simplification in the design. And to the point that you just made, Jim, taking out multi-threading, really skinning everything down, especially on the CPU side, to get to that power efficient and performant CPU design. I think that really is going to be that proof point. I think that's really important for the audience to understand is, they're really trying to hit that power efficiency floor to pretty much refute that x86 can't compete with ARM in terms of, perf per watt. And if they can do that, I think that's going to be a big deal. And then they can, I think they have the convenience and scaling from that point on, right? And I think that's the important thing for everyone to understand, even though I think Lunar Lake, that's going to be targeted really for the ultralight, portable laptops, right? This isn't a desktop, processor. But I think just like what Apple and others have done, they've set a benchmark for themselves and a baseline for themselves on power efficiency, and then they've scaled up. That's what we've seen with Apple Silicon. I can only imagine that's exactly what the Intel folks are thinking. In fact, that is what they're thinking. So
well. And you also have to remember, though, that, they're also playing in another class. You got to remember that we're going to have different classes of AI PCs. Still, if you want the highest performance AI PC, you're still better off going out and getting a discrete GPU. Yeah. So we're going to see a whole different classes. And probably the most important thing is that it's not just a hardware race, it's a software race. Yeah. And we're seeing this not just with the technology vendors, where they're trying to optimize their software and their tools to take advantage of the NPU and the other resources on these new architectures, but we even saw that with the PC OEMs, where they're trying to come out with custom AI applications to help their platform stand apart from all the other PC vendors. So this is very much not just about the hardware architecture, but it's a software race that the technology providers and the PC OEMs are in right now.
Yeah, it's funny you point out discrete GPUs, Jim, because the folks at NVIDIA were quick to point out, hey, we've been doing this AI thing for a long time. And, oh, by the way, the GPU is a really powerful engine. You want TOPS throughput? Well, 4090 has like 1300 AI TOPS, so versus 40 and 50, and we're talking with these thin and light laptops. But it's a different class of product. Obviously, one's a desktop chip and one's a mobile chip. But the other thing that's interesting, Jim, and you touched on it, two things actually. TSMC was the right move. They didn't quite have the process ready for this break in time, this inflection point with the AI PC and mobile. So they made that necessary move, and then now they've got 18A and the Horizon coming in that will help them for the next gen. The other thing that was, I think, probably underappreciated was Lunar Lake's high-speed fabric. So you've got this new fabric topology that connects these two E-core clusters and P-core clusters in a ring sort of topology, and wires everything up. That high-speed switch, that fabric, is huge to have. Performant. It's different than the way they've done it in the past, and you can't even say there's a low power island anymore because there's just this E-core cluster. It's radically different, and that fabric, I think, is they undermarketed that. There's Infinity Fabric has been marketed by AMD for generations now. Why didn't we hear more from Intel on that? Because I think that's some secret sauce.
Well, and the Infinity Fabric is becoming the baseline for the UA link for kind of the alternative to NVLink for accelerators. Yeah. So you're right there, and even on the fabric, and you mentioned the low power island, they went to a much different power architecture to where they have higher level of power gating and more power islands. So they actually have 4 PMICs associated with each processor, just so they can get additional power lines and create that low power island and the high performance island on the same die. Yeah. So, I mean, it is no matter what you think of it, no matter how it turns out in terms of overall performance, just architecturally, Lunar Lake was an impressive chip.
Yeah. Yeah. And they targeted initially for like the 7 or 8 watt power envelope. Yeah. And then they got it back and they're like, oh, we crank this thing up and it does pretty nice things at, 20 watts or 15 watts or whatever. So, it'll be fun to watch when it comes out. I think it's going to challenge Qualcomm. And, the thing of it is, you've got a huge install base, obviously, of x86 software and platform architecture for eons that Qualcomm's going to be fighting. But then again, the battery life story is going to be where the rubber meets the road. How are they going to match up? That's going to be interesting.
Well, and the AI, the applications you can actually run on this.
Yeah, absolutely.
Yeah.
So, all right, let's move on to data center. And so there was the announcement. We knew about Xeon 6 and Gaudi 3. We got a whole mouthful of it at Intel Vision. And so, and any takes there? Any thoughts?
There is one thing that stands out, and I didn't know this until recently, and we're going to get more details about this at the VLSI conference, is that, it's the first product that's going to be on, or the first products, I should say, because they have both a P-core version and an E-core version, that's going to be on the Intel 3 process node.
Yeah.
And that is the third of the 5 process nodes in 4 years. And, I kind of thought of it as kind of a sub node and everything else. I kind of got a sneak peek, and let me tell you, it's not just a sub node. It is a significant improvement, and it's significant because it's also going to be the first advanced process node for Intel Foundry customers.
Yeah.
So, and it's also the first process node, as they outlaid earlier at some of their other events, that is going to have multiple different versions of the process node. So I think that there's kind of an underlying technology there that we didn't get a good grasp of, but also the fact that, and this is kind of a key thing. We've heard Jensen say this at NVIDIA, that the new compute unit is the data center. Well, now Pat's saying that too, and I'll be honest with you, that didn't really click for me until recently, especially I think seeing how Intel's looking at the data center. They used to do hyper-threading, now they're going to the P and E cores, and it really is thinking about not architecting a single chip or a single server, but how do you architect a data center? So how do you have these performance CPU cores, these efficiency CPU cores? How do you have these workload accelerators like DPUs and IPUs? How do you have the process accelerators like GPUs and FPGAs, and eventually even have QPUs for quantum computing? Yeah. And that really, started to hit home of all of a sudden, I understand what these guys are saying now. They're not really architecting a single solution. You have to look at all these different products and how they fit together inside a building, not inside of a single a chassis or a single rack.
Yeah, no, and again, I think this is another case where Intel executives, and in addition to thinking in those frameworks, Jim, Intel executives again showing serious confidence. Sierra Forest, again, up to 288 cores, core density per socket. Trailing situation or trailing position that Intel was in versus AMD versus Ampere has now been closed, and P-core as well scales up to those kind of densities. So you're looking at two very different products. One's for high performance compute, and one's for basically hyperscaler cloud. You need as many cores as you can throw at it as efficiently as possible with Sierra Forest. They really kind of rethought everything, and finally broke away from the paradigms that they were locked in with previous generation Xeon. To me, it's a mark that not only is are the teams executing now, but Gelsinger's leadership, I think, is kicking in pretty hard.
You want to know what's really scary? And I didn't get this until afterwards in some later on meetings. Yeah. They talked about how much performance you get out of the E-core with Sierra Forest. Remember during Lunar Lake when they talked about this 40%, I think it was, improvement in efficiency with the E-cores? Yeah. Well, Sierra Forest is using basically the Meteor Lake generation of E-cores. So think about the next generation of server processors, so Xeon 7, and being 40% or more improvement in performance efficiency, and you're like, holy crap, that's going to be a huge jump. No, that's a good point. I forgot about that. It's basically, it's obviously scaled up and scaled out Meteor Lake E-cores, but when it's Lunar Lake,
style architecture with those E-core improvements should be impressive.
There's more coming.
Yeah. No, I don't know. Honestly, to me, and this was my takeaway with Intel's ITT. I thought it was a good job on them for getting it out there just before Computex, so they had everybody's undivided attention. But they also, I think, their messaging was really crisp. And it's just, maybe it's because they kind of waited for this point in time to bring it all out, and really disclose at Computex, and they focused on this moment in time. But just crisp, good delivery, encouraging. The devil is in the details once we get product in hand and once it starts hitting major data center customers. But so far looking good.
Yeah, and so I want to go back to the comment that Jim made earlier about it's about the data center. It's interesting that you say that, because I think one of the things NVIDIA has done is, and maybe this has affected Intel's thinking a bit, it's gotten everyone to think in terms of supercomputing, right?
The whole rack.
Massive farms of compute to serve certain massive workloads to solve massive problems. So, but I think it'll be interesting to see how all that thinking plays out. I mean, I think there's a diversity of compute out there that will still be catered to by x86 and some of the more conventional thinkings that we've had about data center compute. If we do look at, and this is a point that actually, Jim, you made before about GPU, is it provides you with a programmable accelerator. That's a different mindset than what we've seen previously with more CPU-centric thinking about data center compute. So I think there's there may be a reconciliation of thought that has to happen between what Intel is doing and what NVIDIA is doing, because they're both uniquely positioned to drive a different thread of narrative and reality into data center going forward. And so, but I think that's a really interesting point that you made, Jim. Just wanted to throw that thought out there. Now, anyone want to make a mention of Gaudi? Nobody gave Gaudi any love. Gaudi 3.
Gaudi, yeah, I guess it probably didn't. It did get underserved a little bit because it was pre-announced before we knew quite a bit about it going in. But Jim actually made a tweet that I thought was very much on point, and that was the price points of Gaudi versus NVIDIA H100 versus Hopper that's widely deployed H100. What were the numbers, Jim? It was like 2/3 the price or something like that.
Yeah, it's significantly lower, and rightfully so. Intel is being realistic about it. They're not going after the AI factory. They're going after the enterprise customer who's price sensitive, who doesn't need the latest and greatest performance, and maybe likely more focused on inference than they are on training.
Right.
So it's a solution, but you also have to remember that Intel's got a major architecture change coming in 2025, where they're combining the GPU Max series and the Gaudi series into a single one, and it will be programmable. So it is, and it will support one API. So it's going to be a major inflection point for Intel. So Gaudi's a solution, but I don't think it's, and Intel will even admit it's not going to compete against Intel and AMD in the data center, in the training data center.
Yeah. No, versus Blackwell, which is a beast that NVIDIA built, full cab solution with NVL72. It's just a different animal. Power wise, different animal in terms of what it's good at. That's a big training machine. It does inference as well, but it is a super high power, your power budget's going to be up there as well. So it's a different type of solution. But, Jim, what do you think about that? And Leonard, what do you think? What's interesting to me is Intel and AMD both don't sell at the cabinet level.
Yeah.
NVIDIA does because they can, because they have such a command of the AI compute ecosystem currently. How do you think that's going to pan out moving forward? That's an interesting dynamic because, if you look at AMD even too, they've got, Instinct, they've got, Epic, they've got Pensando for DPUs. I mean, they've got kind of a soup to nuts solution as well as the Xilinx FPGA accelerators. So a formidable opponent there, all the tools necessary on both sides to fight this NVIDIA momentum that is unstoppable seemingly.
Yeah.
You go first, Leonard.
Yeah. I mean, I think it's NVIDIA is taking advantage of its integrated stack. I mean, people, they oftentimes allude to Apple and what Apple does with their integrated proprietary stacks and just delivering modular data supercomputing in a box. And they now have the gravity in many different aspects and dimensions to push that. I think the ecosystem relationships that Intel and AMD are quite different. They have a different philosophy. And I think that philosophy is what really gets in the way from emulating what NVIDIA is doing. But that's not to discount the fact that in the supercomputing world, Intel and AMD have some pretty significant chops. And so I think that's where the industry might be forgetting that x86 actually has a pretty huge, massive track record and ability to scale that's being underappreciated at the moment. And definitely NVIDIA is disrupting in kind of, it's hard to say that they're commoditizing because these boxes and systems are so expensive, but that's effectively what they're doing in the supercomputing world, and that, call it HPC, but really that supercomputing end of it. And that's just my 2 cents there.
That's a good observation. And then Jim, you should jump in here. But yeah, I think when you look at NVIDIA's solution, it's wrapped up with software. It's wrapped up with platform. If you want to test it, you can hop into their data center and try some instances there. All kinds of solutions from Omniverse Enterprise to you name it.
I was just going to say it goes even farther because they actually use AI and Omniverse to actually generate what that data center looks like. But I think all three of these guys are going in the same direction, having all these different pieces of the puzzle. And, NVIDIA, I would say, kind of has the advantage, especially in terms of the interconnect. There's nothing competes with NVLink, so they're coming up with UA Link. Right. As a collective, as an industry collective, to try to have something, but nobody still has anything to really compete against InfiniBand either. Right. So NVIDIA's got InfiniBand, they've got their own Ethernet solutions with Spectrum X, they have their own, they've got NVLink. I would say, to your point, Leonard, I think it's really important that, for these general purpose data centers or the AI data center, the x86, this multi-configured architecture and everything else still has the advantage. But in these really high-performance supercomputing data centers where you need to architect everything else, and once again, I'm going to say it again, the new compute unit is the data center, and you have to architect a data center like you would have architected a server before. Yeah. And that's where NVIDIA, I don't see anybody touching them right now. Now, I do think AMD and Intel are going there, but they don't have necessarily the same tool set, and and they're still on the learning curve that NVIDIA has kind of pioneered.
Right. Yeah, it's amazing how well they've fleshed out the platform and the complete solution versus what feels a little bit more like piecemeal from AMD and Intel, where here's our CPU, here's our GPU, and oh, by the way, we have this unified software stack. And it just seems, it's more hand tooled versus NVIDIA that just says, here's the whole platform, here's the software, here's, oh, by the way, you want to train some models, we've got this. It's I guess just more refined because obviously they've had decades of experience in this ahead of everybody else. But yeah, Leonard, good point. I mean, x86 isn't going anywhere.
Yeah, and I mean, because you hear Jensen say that all the time. Accelerated computing is going to basically take over everything. I don't know about that. It depends on what you mean by accelerated computing and what's the architecture. But I'll leave you. I'll leave our audience with this thought. It's how much of a market really is there for all of this supercomputing, right? Because that's what we're looking at the moment for doing these large language model, mixture, expert, and beyond training. Right now the demand is very high because there's a lot of investment going in there. But there always has to be end market sustainment of these types of compute, and historically this stuff has been pretty niche, right? And the question I think everyone has to ask themselves is how large is this market really from an end market perspective? And so I think my feeling is this: I think Intel still has a good position, especially outside of what may be may hypothetically be a niche, may hypothetically be the next big thing. But Jim, to your point, Gaudi, the portfolio at the moment is geared toward inference. Okay, this assumption that a lot of the large language models will eventually get compressed and brought down into the edge environments where they actually do something, and that will likely be where the larger opportunity is. And so anyway, I guess we'll leave the audience with that. But unless there's any final words.
I have one. I'll leave you with a teaser. Where you think AI is today isn't actually where it's at. Just some of the tests we did over the past couple of days blew my mind. So I would say the market and the opportunity is huge. And what we can do, which most people don't realize today, is it blew my mind. It just put it this way, just some of the simple things you can do with software using a mixture of experts, using RAG, using everything. It breaks down the walls of AI and agents to a point where it is faster, more performant than humans can ever be. It is unbelievable.
Look at this guy.
I don't disagree with that, Jim. I think there's a lot of growth to be gained from just the evolution of this. So the more we can do and the more we get done with it, the more the need is going to drive the need. I wonder if we're going to reach a saturation point at some point. It can't go on endlessly. Once we have these amazing, clusters in the cloud of huge AI compute engines, we got a 10x performance improvement in a lot of AI applications for ChatGPT, just going from A100s to H100s. Yeah, and we're going to see likely more than that with Blackwell. Yeah, and on and on and on. So just think of what these agents are capable of.
Oh my God. Jim, don't ruin the moment. You laid out the perfect cliffhanger. Okay,
you got it.
I'm gonna cut you guys off. But anyways, hey everyone, thanks for joining us. I hope you found this discussion insightful. I certainly did, and it's great to have you gentlemen on. We're going to be doing collaborations going forward, probably on a separately branded podcast, but it's been an absolute pleasure and honor to have both of you guys on. I know we talked about doing this for quite some time, and it's great to finally do it and get you on, Dave. Dave, I've been trying to get you on for quite some time, but anyways, yeah,
we didn't run fast enough from him, Dave.
Oh boy.
Well, hey,
nothing but love, Jim.
Yeah, so thanks for joining us, like I said. And if you would like to get in touch with Dave, Dave, why don't you share your information with our audience?
Yeah, you can find me on the web at dave@hottech.com. That's my email address. HotTech.com is the Analyst site. HotHardware.com is our web press site that caters to consumers and IT professionals, but we are analysts as well on the other side of our house. So you can find us a lot of places, hothardware.com, hottech.com.
Jim?
Definitely look for us on TiriasResearch.com. My contact info is jim@TiriasResearch.com. It doesn't get any simpler than that. But also look to us through our media partners as well. We've got our own YouTube channel and obviously working with these guys. So look for more of that, but also, look for our stuff in eJournal, eTimes, ECT News, Microelectronics in Taiwan, as well as Forbes.com.
Yeah, we're there too. We're at Forbes and a couple other places too. So good point, Jim. Got to talk about the verticals. And Leonard, you've got stuff everywhere. You're pervasive, like
I'm all over the place. Yes, I'm the omniverse.
The Omni Analyst.
Yeah. So, anyways, please make sure that you check out Next Curve at www.next-curve.com. Subscribe to this podcast. We're on YouTube as well as on Buzzsprout, so you can listen to us on your jog, your daily commute, on your favorite podcast platform. And thank you so much, gentlemen, and we will see you next time.